was an Wi-Fi issue at my end. So today our speaker is Miss Manpreet Budhraja. So she is an NLP practitioner and she currently works as a data engineer at Packt. She's creative by nature, enthusiastic to help, and she builds community and mentors students and professionals. So today, Manpreet is going to cover the basics in NLP by explaining real-world examples. She will be talking about advancements and changes in NLP, and she will also be going to show hands-on coding from the basics. So without wasting any much time, let's get started. Over to you, Manpreet.
Yeah, thank you so much for the introduction. Means a lot to me. Hello, everyone. I would like to keep this session interactive. So, if you have any questions at any point, you can unmute or ask or put it into the chat section. It would be good if you make it more interactive. It would be a good learning. Moving forward, NLP as a field has been growing very fast, and with the recent advancements, if you would have seen that Hugging Face partnership with Amazon and using its cloud services is something gonna transform a lot of things. And then you have papers from Attention Is All You Need and Transformers, Birds, and also a lot of change has come in NLP from a very long time now. And I'll be talking about the basics in NLP, which include your regular expressions with tokenization, sentence tokenizations, and stuff. So let me share my screen. Yeah, let me know if you could see the screen or not.
Yeah, we can.
Okay, so uh, when you talk about text, so its basic atomic unit is its word. So I would like to ask you all this question. What do you understand when I give you this word called house?
Four walls.
Okay, good. Next. Let's make it interactive. So, what do you understand by the word house? If I give you to tell me what comes into your mind when you hear the word house.
A shelter or a refuge.
Okay. Anyone else?
There are some answers in the chat box.
Yeah.
Yeah, okay.
I saw a place to live, security and protection, basic requirement. Anyone else? Okay. Now that I gave you a word house, you told we generally have this perception that house is something we have four walls, roof, doors, and windows to live. But what if I add to it the White House? It totally changes. It changes to President's House, the US President's House, or I say the Red House. It changes to a particular house which is red in color. So in NLP, it's very important. A single word in it itself doesn't hold any meaning, but the words around it has a very important meanings because it changes. It's the meaning of that sentence. Suppose you know that we studied it in our school. I went to the banks of River Yamuna, or this next sentence could be I went to the bank to get my check cashed. So both are the word banks, but both hold different meanings, and we get to know its different meanings just because you know the words associated with it. So similarly in NLP, it's also very important when you pre-process everything that you know that it's words have the meaning changes of the words when a whole sentence gets attached to it with the words around it. So she's gone off the deep end. Okay, so she's gone off the deep end means that she is very afraid, but deep end might mean something else. Now, when you're doing speech to text, is also a type of NLP because you're converting a speech into text and then pre-processing it. So when you hear conversations, there are a lot of times that you would see would be some fragments or fillers. So fragments are like and fillers would be like I get it. You're telling right. So are the fillers to fill the pauses between your sentences, and fragments are when you get stuck. So these are also the disfluences you would see in your real time text if you get to pre-process. Okay, so this is something very basic called word in NLP. Now, moving forward, we have an algorithm called max match algorithm. So, before we move ahead, can anyone volunteer me to tell what does this word would be? Can anybody from the audience volunteer to answer this question?
Yes, shall I?
Yeah.
Women 4.0 webinar is live.
Yeah. So you break that whole one big sentences into some few words because you know it would make sense, right? Next one. Anybody else?
Max is studying right now.
Can I?
Yeah. Okay, you can go for the next one.
World is suffering from corona.
Yeah, and the last one is Corona is
Corona is
dangerous.
dangerous.
Yeah. So this is basically you are dividing this into simple sentences, but uh, the real life algorithms actually don't know that it is woman 4.0 webinar is live or not, because there's a high possibility that the corpus they have, so corpus is a collection of text that you have, okay, that may include a lot of text, tokens and everything that you created before doing anything in your text or anything you want to do. So when you have this corpus, you will have a lot of things in it. So what this algorithm does is it matches one word and see is there anything with W? No. So goes to the another letter. W. Does W exist exist in your corpus? No. So it would go to the third word. Does WOM exist? No. So then it would again go to this WOME. Then it would go WOMEN. Now he finally got a word, so it would store that as one word. But this algorithm generally fails in your English text. We'll see how below, and it's generally preferred for your Chinese language because they don't write words with gaps. So this was preferred more for Chinese language than English language. It's not preferred to use this algorithm in English languages. Now, for example, okay, now that you have this corpus, let eating it be eat, eatery, eatrest, a seater, and now you have this question. So what it would be now? Anybody? You have this corpus and now break this into the letters like you did before.
Let it be a
Let
seater.
it be a seater.
Let it be a
Yeah.
seater.
Yeah, let it be a seater, but it could be also that let it be as eater also. If it's not this corpus, we could have seen it as eater also, right? Next one.
The table down there.
The table down.
No. Theta, because you have the longest word. So it would match the longest word. Theta, then bled, own, there. So it would not be the table down there, but it would be theta, bled, bled, own there. So it matches the max thing. So that is why it's called a max algorithm. Okay. Now the next thing we would see is the minimum edit distance. Given this word, what do you think your mobile would predict to give you the correct word? As graph or giraffe?
Graph maybe.
Okay.
Giraffe.
Yeah, giraffe, because it's more similar to what it's trying to tell rather than graph. So when you see Grammarly, it would tell you, sorry, it would tell you graph because it's just one letter deletion from this rather than adding so much of these letters to it. Sorry. So when you write this, it would tell you graph, graphic. Okay. So because this word is most closest to this word, because when you do the deletion, substitution, addition, the score is the least when it comes to graph rather than giraffe. So that's why it's preferred graph. So in your WhatsApp also you have this thing telling you to write the right spelling. Hey, hope you had a good day. Do you want to go for running or running? So you would prefer running. Okay. So this algorithm works in this way, like auto correction in your WhatsApp. So minimum exit distance between two strings is defined as a minimum number of editing operations like insertion, deletion, substitution that need to transform from one string to another. Now I'll take you to the coding. So its basic application is used in automatic spelling correction. In bioinformatics also you have DNAs, ACGT. So this to maintain the sequences, it's also very important to use these. So that is why you use minimum edit distance over here. Okay. Next, I'll take you to this code. So we have this library NLTK, which is Natural Language Toolkit, which is most used library to pre-process your data. We are importing the word tokenizer, the sentence tokenizer, and the n-grams from it. Okay, which we'll study further what is all of these. And we have a test sentence over here. Well, to my surprise and delight, everything was right as possible till afternoon I left at 2. Okay, and now we use a sentence tokenizer. So what basically the sentence tokenizer does is divides your sentence into tokens. So this is one token. It divides only on the period. This is the second sentence, second token, and this way it's the third. Okay, so it divides your sentence on the basis of the period at the end of the sentence. So why do we need all of this? We need it because we need to process a lot of text when we are making applications like chatbots or anything. So it's very important for you to divide them into tokens and work. Sometimes you would have sentences that you wouldn't need them, like the stop letters and words in some pre-processing, like you're making a sentimental analysis. So you don't need stop words, the, and, because they don't contribute anything to your sentimental analysis. Okay, so this is tokenizing by sentence, and then you tokenize it by words. This is words where you haven't removed the punctuation marks yet. So well is one token, comma is your one token, two is one, my is one, surprise, comma is one. So in this way, even your punctuation marks is counted as a token if you don't remove it. What if you remove it? So you could see the difference. Well, to my surprise and delight. So all the punctuation marks from here got removed. So we don't need at times some punctuation marks. So we remove the stop words. We remove punctuation marks from our text to pre as a pre-processing thing, which is also called feature engineering at times. Next is we call the implementing the minimum edit distance that we study now. So banana to Bahama. This is your target word and this is your source word that you wrote. So from this to this is a change of 2. This to this is edit is 1 because you're just substituting 1. From this to this it's 5. So this is how you have a library in your Python to do this thing called minimum edit distance calculation. You don't have to make your own formula, you just have library. You need just use this library to evaluate the distance between the two of them. Any questions so far? Okay. Moving forward, we have path of speech. Okay. So your path of speech plays a very important role because text like translations and stuff you need to know, or name entity recognition you need to know what part are you trying to find out of it. Like she saw a beer and your efforts will bear fruit are two different beer here. Like there beer means noun and the next sentence beer is a verb. So it's very important for you to understand your model to understand that what type of part of speech are we tagging and working in. Example like Washington, Seattle, Washington is a geolocation, but George Washington is a person. So it's POS tags we studied in our school, which are mainly your conjunctions, verbs, adjectives, interjections, and superlative adjectives and comparative adjectives. So these are all your parts of speech that comes in this. So there are two types of part of speech. One is content word. Okay. Suppose you see typing computer, loves conduct webinar, tomorrow going bus. Okay. So they provide you some information. Okay. Typing computer is some information. Loves to conduct webinar is some information. Tomorrow going bus is one information, but it's not a whole complete information about anything. So these are generally your nouns, verbs, and adjectives and adverbs in your content word. And they have a proper list. They don't generally the new not generally new words so often added to these words. Okay. And then you have function words which make these a sentence complete. He is typing on computer. She loves to conduct webinar for tomorrow. I'm going through bus. So these function words are basically joining everything and making it in a proper sentence, which is, and this includes pronouns, prepositions, conducting conjunctions, interjections, and determiners. Okay, so you have these many of parts of speech in when you're pre-processing your NLP. This is list, marker, modal, noun singular, adjective. JJJ means adjective. JJR means adjective, comparative. JJS means adjective, superlative, cardinal digits, determiner, and so much of your parts of speech are there in this. Okay, next is regular expressions. I would say that regular expressions is very important, and I feel it's underrated because sometimes at work you don't need to create such models. You just tell that if the string contains this and this, put it into this category, or if string contains this, put it into this, or extract if the string contains this. So when you work with real world, also regular expressions is important. You might use it when you fill a password um, in making a new account, and they would say it must be a lowercase, must be an uppercase, must have a special digit, must be 10 digits long. So that's a type of regular expression they would have defined for to validate it. And in regular expression you have like clean star, which means zero more occurrence of the immediately previous characters, or regular expressions like supports is D star, which means zero or more than one digit, more than zero digits occurring. So if your text is A B C D E F G 1 2 3 and you put D star, so you have a lot of digits in this or no digits in this. Okay, and clean plus means at least one or more than that. So there should be at least one digit in your or anything, the type of regular expression you're trying should be there in that. Okay. So when you see the code over here, this means search the strings matching with small t the and capital T the. Search the first white space that occurs in my text, split it by white spaces, which is actually it would tokenize it. This is print the part of the string where there was a match of words of capital S. Okay, capital S के आगे जितने भी words आ रहे हैं वो उस word को match, it will match it. Replace your white space with at the rate. Find all the letters matching TER and star. So if it's forget, or so suppose eater, so it would match eater as well because TER, or if it's forgetter or something word like that, we take it. So it's ETRRR. So it will even catch that word. ET2, ET, this curly bracket 2 means that E followed by exactly 2 T's. Suppose it's forget, so it would only take E double 2 T. So you have the matching from the first one. The first white space is at the fifth position. The next is to split by white spaces. So if you see it's at 5 because W is 1 2 3 4 space comma comma space. So after 5 it's the first blank space. So and here you divide it by a white space. Well, to my surprise. Next is to get this letter where S is capital followed by other letters. So Saturday is there only in our text, and similarly for this TER and ETT. Okay, now this POS tags in our this NLTK library that does the POS tagging. And you would see that well is labeled as RB, 2 is 2. So these are all your that I showed you the list. So it is all that. CC means conjunction, it's verb, and in is interjection, JJ is your adjective, DT is your determiner. So in this way, it happens this way. Now you could see with frequency distribution your top 20 POS tags. So in your text, the noun is 21, interjection is 21, verb is 17, prepositions are 16, determiners are 13. So these are your top 20 POS tags in this. Okay. So far, any doubts? Any doubts so far, anyone? Okay, I'll proceed. Now, moving ahead, morphology is the study of the way words are built up. So, if you see that words added are to es, like smile, smiles, toy, toys. So s and es are added to it. Or suppose running, run, running. So you're adding ing to it. So that's why it's changing over here. So there's a one thing called text segmentation. It's the process of dividing a written text into meaningful units, such as words or sentences or topics. This is very important because in tasks like information retrieval, Google search also adopted stemming. In sentimental analysis, you don't need to analyze the same word again. Suppose it's there, and the happiest person in this happy world. So happiest almost means the happy. So you convert it to its root word happy. So that's why you do these things to clean your text. So it's a part of your pre-processing, like stemming and lemmatization. So stemming means the root word is the part of the word to which you add influences like ed, s, misunderstood, or something like that. And lemmatization means, like, unlike stemming, it reduces the words to its root form. For example, runs comes to running, ran comes to run, are all the forms of run. So you don't need every time running, ran in your text. It ultimately means run. So that's why you pre-process all of these things. So do you have like Potter stemmer and Lancaster stemmer? So Potter stemmer does not often generate stems that are actual English words. So it's generally used for simplicity and speed. And Lancaster stemmer is like an iterative algorithm. We would see how it happens in the code, and but it's very heavy, and generally we don't prefer stemming. We would prefer any day doing lemmatization over that. I'll show you why. So here we have used Potter stemmer and Lancaster stemmer. So you see the word well is taken well here and wel here. And surprise is taken as surprs, surpr. So you see table is made cut down to tabl, which I think is like reduces and makes more noise in your data set. So that's why we prefer using lemmatization. Well is well, two is two. Was root form is b. If you see was b. Um, where bid, bid, complemented, complement. So you are turning them into your root forms. Okay. We read about the tokenization. It's actually breaking up your sequence of strings into pieces, words and keywords, and phrases into small tokens so that you can use it in your modeling and stuff. So next we have a Ziff law. It's a discrete probability that tells you the probability of encountering a word given in a corpus. Suppose the biggest tower in the world is the Eiffel Tower. So calculate the probability of the is 1 by 3 by n, where n is the total number of tokens in your corpus. So that's how you do this Zipf's law. Okay. Now you have language model, the last topic. So whenever you do Google search, it would tell you a lot of these things, and it might differ from what me searching to what you are searching. Machine learning case studies, machine learning applications. It would be based on my researches. While if you do, it would show something else. And if you have here like you can, you are, you you have to, you will do, you want, you need, you know. So these are all things that are predicted, that given the word you, what are the given the word can and you, what is the possibility that these might be used. Okay, so this is all called your language modeling, in which we use probability basically, which we studied in class 12, that given the probability of event A, what is the probability that event B will also occur. So here is the same. Given the probability of word the, what is the probability that the by transition occurs after the. Okay, and it's used in Google search, messaging on phones, in Gmail. Now that you say it predicts what do you have to write further in machine translation tasks and stuff. So model that assigns probability of words are called language models. And the probability of a word W given some history H, P W by H, and the assumption that the probability of a word depends only on its previous word is called a Markov's assumption. So given its water is so transparent that, given the probability of this, what is the probability that the will occur after that? Okay, so word is the, and history its water is so transparent the. And that's how you calculate your probability. So here you calculate 1, 2, 3, 4, 5, 6 words after this. Generally we use unigrams and bigrams or trigrams. Like if you see here, we calculate the frequency of words. The is 8 times, and is 8 times, me is 7 times, was is 6 times, 2 is 5 times. Okay, and we calculate the bigrams is just giving them the tokenized words we did. And then 2 means if we want to do it in the pair of 2, if we give it 3, it will look at 2 words in the history, and we are just taking the top most 10 out of it. Okay, was there comes 2 times, 2c comes 2 times, see that comes 2 times. Similarly the diagrams. So this is a very basic intro to your NLP thing. That's all from my end. I'm open up to questions if you have any.
Hi Manpreet, we have some questions lined up for you. So the first question is, which NLP courses can you recommend to beginners?
I would say read Daniel Jurasvi's book or his Stanford course. Might find on YouTube, or you might have to torrent. But it'll get on YouTube, I guess. CS something course is there, but by Dan Jurasvi. It's his basics are quite good. I would seriously recommend going through that, then reading his book, and start reading research papers.
Okay, thanks. The next question is how to start with NLP as a beginner.
Take a paper like Word to Vec, start making these small codes, applications, whatever you read, try to code it, read it, and implement it. And till then you don't practice it, you don't get it. So start practicing it by doing small projects. You have a lot of things now available, Kaggle competitions. You have a lot of data set available everywhere now. So just take the data set, start doing something on it.
Yes, definitely. The next question is, can you talk about Stanford Parser and maybe explain its working?
Okay, Stanford parser, as in you mean the NLP parser for name entity recognition that it has. I used the Stanford parser for like name entity recognition, but I would prefer using Spacey um, rather than using Stanford because Spacey has much more good models, custom built models, and they have like good libraries to do stuff rather than using Stanford. So any day I would prefer using the things, but I don't know much how to explain that in detail.
Yeah. So the next question is a very commonly asked question. Will you tell us some basic projects that we can do in NLP?
Okay, you can do text mining projects. It's a very basic project in NLP, and once that you start learning deep learning and LSTMs and RNN, start using use implement paper first or do a project to sentimental analysis using RNN, LSTMs, then use doing BERT, use doing transformers and see what is the difference. It would be a good study because there's a reason why these came because something at past had failed. So that's why you have now transformers, attentions and all. Try reading papers. Try implementing papers because when you implement a paper, you learn a lot. That's what I say. But then you have a lot of things you could build up. Can take part in hackathons also as a beginner in a team, and then you can build up projects around it, do sentimental analysis. People being so creative now are analyzing and doing stock markets, where understanding the stock markets based on government policies and how people are reacting to it, that is affecting the stock market. You have COVID, how people reacting to COVID. You have Reddit data set that you get. You could do sentimental analysis. You could do question answer generation. You can create machine translations. There's a lot you can do.
Yeah, sure. The next question is, which languages do we need to learn for NLP?
Python. Nothing more you need than Python. And you need to know how libraries work and be good at maths. Because there's a lot of linear algebra, partial differentiations, and space thing involved. So be good at all of these things.
Okay, so the last question of the day is, can you tell about the career opportunities in NLP?
There are a lot of nowadays companies are taking NLP into consideration, but I'll tell you a very honest thing. Sometimes you don't need to build at work even these high level models. You just need to use simple regex and manual classification, and thing is done. But in research, there's a lot of things going on, and if you see companies like Microsoft, Amazon, Google, Amazon developing its Alexas for Indian languages, responding Alexa to Indian languages. Google Home is already doing well with Hindi. So That's how NLP is being used everywhere. And role, it depends upon your projects you do and how well you are approaching other companies.
Yeah. So the questions are over. So I would like to thank you for enlightening us with your knowledge. Today's webinar was full of knowledge and interesting things. It gave us deep insights of NLP and also revealed some interesting facts. I'm pretty sure that this knowledge will help us all in our studies as well as our future. So thanks once again.
Yeah, you're welcome. Thank you.
Thank you, Manpreet. It was lovely to have you.
Yeah, and if anyone wants to connect, they can connect with me on LinkedIn. And yeah.
Yeah.
If you want, I can share my LinkedIn link in the chat. So if anyone wants to connect, can connect with me on LinkedIn. Thank you. Bye.
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 Bye.